Hello friends, welcome to the channel. Today we are going to learn what is ETCD and why we use it in OpenShift cluster. Have you ever wondered why OpenShift cluster completely depend on ETCD node? What happen if the ETCD leader goes down? Can we manually change the leader, and during disaster recovery which backup file is actually required? In this video, I will explain ETCD in OpenShift with real world example and interview questions. So, take a look. What is ETCD? In the OpenShift, ETCD is the critical. It is a distributed key value database that store the exact state of your entire cluster. It acts as the brain or the memory of the platform. ETCD holding configuration data, secrets, networking settings, and the state of the running pods. So, these are the functions of the ETCD. Now, we'll look about why do we use it. So, ETCD maintain the source of the OpenShift control plane relays on the ETCD to enforce the desired state of the cluster. Why ETCD needed? Because the control plane means our master node relies on the ETCD to enforce the desired state of the cluster. If you request 5 replicas of the application, ETCD record this and the controllers then read this state and create the containers to match it. Means if you request some replicas, so that request goes to the ETCD node and ETCD node record this request and the controller read this request and create the container to match your replicas. So that's why we use the ETCD. Now another feature is it provides high availability. How it's provide the high availability? Because ETCD is a distributed and use the Raft Consensus Algorithm. It replicates the cluster state across multiple master and control plane nodes. If one ETCD node fails, the other members seamlessly take over and ensure your cluster never lose its memory. So here we see how the ETCD node provide the high availability. ETCD provide the high availability with the help of Raft algorithm. That Raft algorithm means it use the consensus. Consensus means the group of discussion. So based on the discussion, the ETCD node select the leader. Now third point is it handles watch events. Now what kind of watch events? That is, unlike traditional database like MySQL, ETCD allow OpenShift components to watch for specific changes in a real time. The moment a configuration is updated in ETCD, a notification is sent instantly to the relevant controller to execute the change. Then fourth point, it store critical secret securely. It securely holds sensitive data like authentication token, config maps and passwords, which OpenShift then encrypt to keep your workload safe. So these are the four parameters ETCD securely handle. Then core concept and best practice, the operator. In OpenShift, ETCD is managed automatically by the ETCD operator, which monitor cluster health and correct any differences between the current and required state. Then quorum. ETCD required a majority of nodes to agree on any data return, that is 2 out of 3 or 3 out of 5. If a majority node fails, the cluster goes into read-only mode to prevent the data corruption. Quorum means suppose you have the 3 master node and out of the 3, one master or 2 master node goes down. So that time etcd node goes to the quorum. So that time etcd node select the leader and your cluster goes to read only mode state. Means you cannot deploy anything on that cluster, but your production is running on the same time. Then disaster recovery. Because the entire cluster forget everything, if the etcd is destroyed, regular backups are absolutely mandatory. Disaster recovery means you have to take backup of the etcd node every day or in a week. Why? To avoid the disaster, to avoid any production related challenges. Now talk about the Raft algorithm. Raft algorithm is a method used in distributing system to make sure multiple server agrees on the same data even if some server fails. For example, imagine three friends are maintaining the same book. Friend A, B and C. Only one friend is the leader at a time. Then how Raft algorithm is work? Leader election. If there is no leader, all server votes. The server that get the majority vote become the leader. For example, A gets 2 out of 3 votes. A become a leader. Then we talk about the log replication. Client send a request only to the leader. The leader records the change and send it to the follower. For example, client add a user John. Leader A write it in its log. A send the entry to B and C. Once the majority 2 out of 3 confirm, the change is committed. Then we talk about the failure recovery. If leader A crash, B and C notice the leader is missing. They start a new election. Suppose B wins, B become a new leader. Server state in Raft. How the server state in the Raft? Raft follow the below algorithm like follower, candidate and the leader. Follower. Who is the follower? Receive update from the leader. Who is candidate? Request vote during an election. Who is the leader? Handle client's request and replicates log. Now talk about the key benefit. What are the key benefit? High availability, automatic leader election, data consistency and fault tolerance. So these are the key benefits Raft algorithm are follow to maintain the ETCD node. Then talk about how to change ETCD leader. When the ETCD node issue, that time we can change the ETCD leader. How we can change? First, we check OCGet nodes command. First, we check our worker and master node are ready state or not. After that, we debug one of the master node with the help of OC debug node slash master node name. And then we log in to the chroot slash host. Inside that, we use the one command crctl exe hyphen ti. Then we use the variable dollar open bracket crctl ps hyphen hyphen label. Then we use io.kubernetes.containers.name is equal to etcdctl, and we use hyphen q open bracket complete and give the bin bash shell like slash bin slash sh. Once we enter that shell, we check the endpoint status with the help of etcdctl endpoint status hyphen w table. So in that table, you can see the endpoint, then ID, version, DB size, is a leader, is a learner. These things you are seen when you can check the endpoint status. Is a leader true means our 192.0.2.1. This is the node IP. So he is our leader. Then move the etcd leader to another node using the command. Which command? etcdctl move leader and then id name. With the help of this command, we can move the leader. Here we can see etcdctl move leader, and we give the second node id, that is start from 8ea and end from C16. Then once we enter this command, the leadership transfer from C7 to 8e. Then check again the endpoint status to confirm leader has been changed. We use the same command etcdctl endpoint status -w table. After enter this command, you can see the node 2 is leader status shows into true. Means our node 2 is our current leader. With the help of this command, we can move our leader manually. Now, on what condition we change the leader in OpenShift? Because we don't have to change the leader manually into the OpenShift, because these leader automatically change with the help of Raft algorithm. But in some condition, we have to change the leader. Why? Let's see. There are practical situations where administrator may manually transfer ETCD leadership. Now, which situation? First, plan maintenance, most common. That is, suppose master 0, 1, 2. This is your master node. Master 0 is your leader and 1, 2 is your follower. You need to reboot master 0 for OS patching, kernel upgrade, OpenShift upgrade, and the hardware maintenance. Before rebooting, you can move leadership to master 1. Here you can see master 0 is the follower, 1 is the leader, and 2 is the follower. This avoids a leader election during the reboot. Then another situation is high load on the leader. The leader handles write request, log replication, coordination among members. If the leader node has high CPU use, high memory use, and high disk input output latency, you may transfer leadership to the healthier node. Now, third situation is troubleshooting. If log shows issue in the leader such as slow disk warning, frequent timeout, network instability, that time moving leadership helps to determine whether the problem is tied to that node. Fourth point is data center or infrastructure work. If a specific rack, hypervisor, or network segmentation hosting the leader is about to undergo the maintenance, transferring leadership first reduce the change of the chance of the disruption. So these are the 4 points we are use when we transfer or when we move the leader from existing to new one. So these are the situations. Now, what happen if you don't move it? Usually nothing serious. When the leader down, followers detect timeout, election start, new leader elected. Means if you not move your leader in that situation, what situation we discussed earlier? In that situation, if you are not moving your leader, that time leader goes down, followers detect timeout, election start, and new leaders elected. So Raft automatically elect a new leader within a few seconds. So manual leader transfer is mainly about making maintenance smoother and more predictable, not because the cluster cannot function without it. How you can give the interview friendly answer? Manual leader transfer is typically performed before plan maintenance on the current leader node, such as patching or rebooting. It allows leadership to move gracefully to another healthy member and avoid election events during the maintenance window. In normal operation, ETCD automatically elects a new leader when required. So, if you cannot move manually, that is also fine to select the leader, because here is the Raft algorithm automatically manage to elect the new leader into the OpenShift. Now talk about how to take the ETCD backup and why it is important. In OpenShift, ETCD backup is a critical task because ETCD store the entire cluster state like pods, deployment, secrets, route, and configuration. What are the prerequisites to take the backup? First, you required cluster administrator access. Then, access to a control plane like master node and OC commands configure with cluster admin privilege. These are the prerequisites we require to take the ETCD backup. Step 1. Check control plane node. With the help of OC get node command, you can see the output like master 0, 1, 2 is in ready state. Then take the SSH to the one of the master node with the help of SSH core at the rate master node. Get the sudo -i root access. Then create a backup directory with the help of mkdir command. Where we create the backup directory? We create a backup directory inside the home core directory. Inside that we create etcd-backup directory. Then run the OpenShift etcd backup script. Now, where that backup script store in the OpenShift, you can see usr local bin cluster hyphen backup.sh. These are the script. With the help of this script, we can take the backup and store the backup to your desired location. This script create the snapshot with the help of timestamp.db. Then create a static Kuber resource with the help of timestamp. And this file is your tar gz file. You can see when you take the backup, similar this kind of file with the help of date, month and year you can see in your shell. Verify the backup files. You can use ls-lh command and your backup directory path. Inside that backup directory path, that file is created with the help of the script. Then check the status. Locate the etcd ctl container with the help of CRI CTL PS pipe grep etcd. With the help of we check the snapshot detail. We use the command etcd underscore API is equal to 3. etcd snapshot status. We can give the backup directory path and our snapshot db file and give the parameter -write -out is equal to table. So you can see the output like this. Inside that table, you can see the snapshot detail and you can also see the hash, revision, total keys and total size of that snapshot. Then copy backup to a safe location. How do we copy? We copy with the help of SCP. With the help of SCP, we can copy this file to our local NFS or local share path. Then verify the cluster health before backup with the help of ocget co command. In that command, when we get the output, we can see all operators should be show the available is equal to true and degraded is equal to false. Then check the etcd pod with the help of ocget pods -n OpenShift -etcd command. All etcd pods should be running when you use the command. Files created by backup. The file purpose is snapshot.db underscore etcd. That file belongs to, see, just a minute. Let me correct this word. See, snapshot underscore dot snapshot underscore star dot db. This is etcd database backup file and static underscore cube resource underscore star dot tar dot z. This is static pod manifest and Kubernetes resources. These both files are very important when you are taking the backup. This file should be present when you initiate the backup. Both files are required for full disaster recovery. That is the main point. Now we look about the interview perspective. To take etcd backup in OpenShift, we logged in to a control plane node, run usr local bin cluster hyphen backup script, give the backup directory path, verify the generated snapshot and static resource file, valid the snapshot status, and then copy the backup to the external storage for a disaster recovery. So, with the help of these command, we can take the backup of the etcd node and we ensure that that backup should be transferred to your disaster recovery storage. Now, the question is that which file is important to store the etcd? We'll look those files. First one, snapshot underscore 2026 0603, then number.db. This is the most critical file. This is the actual etcd database snapshot containing. What that snapshot containing? It's containing Kubernetes object, namespace, deployment, pods, services, secrets, config, route, and cluster configuration. Without this file, you cannot restore the cluster state. This is absolutely right. Then second one, static kube resources .tar.gz also required. These contain static Kubernetes resources and manifest, including control plane configuration needed during disaster recovery. Example, static pod manifest, cluster configuration file, control plane resources definition. So these are the examples. Now talk about the interview question. If asked which file is important for restore, you can answer the snapshot db file is very primary and most important file because it contains the etcd database. However, OpenShift disaster recovery requires both snapshot db and static kube resources files. So both files should be backup and preserved together. So today we see that how etcd is very important into the OpenShift cluster. What happens if the etcd leader goes down? We see how etcd node automatically select the leader within a few seconds. I hope you enjoy this session. Thank you for watching this video. I hope this etcd and OpenShift tutorial help you better understand the leader election. If you found this video useful, please hit the like button and subscribe to the channel for more OpenShift videos. And also don't forget to press the bell icon so you never miss the future tutorial and interview preparation videos. Thank you for watching. Have a nice day.